Okay, so now we're going to look at some exponential equations. We're going to introduce one method for solving exponential equations, and by the end of chapter 6 we're going to have a couple different methods. We're going to start with the simplest method first, let's say. Alright, now if you think back to our exponential function graphs, okay, we've got that L shape, and you'll see that exponential functions are one-to-one. Remember the horizontal line test. So if they're one-to-one, then that means the definition is that if the function values are the same, then the x values have to be the same. Okay, or in other words, if the function values are not the same, then the x values can't be the same. So what that means is if we have an equation where we have two exponential functions, same base, then the exponents have to be the same. So this is one way that we can solve them if we can get them to the same base. If we can't get them to the same base, then this method doesn't work and we're going to have to learn a different method later. Alright, so what that means is if we have something like 2 to the x equals 2 to the third. Okay, 2 to the x equals 2 to the third. You can see that the bases match, so the exponents must be the same. X has to be equal to 3. There is no other value of x that could possibly make these two things to match. X has to be equal to 3. Okay, so it's kind of a basic one. Let's look at one where there's a little bit more going on. Let's say we have 3 to the 2x minus 1 equals 27. Okay, 3 to the 2x minus 1 equals 27. So the first thing we need to do is see if we can get the bases to match. We've got to get it, it's got to look exactly like this for this method to work. So can we get the bases to match? And the answer is yes. We can get them both to a base of 3. So this one's going to stay the same. And 27 is the same as 3 cubed, 3 times 3 times 3. So now the bases match, we're in the right form, and the exponents must be the same. So this must be equal to this. So now our equation becomes 2x minus 1 is equal to 3. We set these two exponents equal to each other, and now we have a linear equation to solve. I'm going to come over here to give us a little bit more room. So we add 1 to both sides, and we divide by 2, and we get that x is equal to 2. And you should be able to come back over here and plug that in and check it. If the numbers get a little unruly, you can always use your calculator to check it as well. Okay, so x equals 2 is our solution. Alright, let's try another one. Let's say we have 9 to the negative x plus 15 equals 27 to the x. Okay, so 9 to the negative x plus 15 equals 27 to the x. And we want to know, can we get it into this form? Can we get the bases to match? Well, be careful here. 9 times 3 is 27, but we can't get these both to a base of 9. It has to be 9 to the something, not multiplied. Okay, so can we get these to the same base? The answer is yes if we use 3. So 9 is the same as 3 squared. And then we're going to raise it to the negative x plus 15. And 27 is the same as 3 cubed, and we're going to raise that to the x. Now this is where our exponent rules from the review video come into play. So if I have a base raised to two exponents like this, remember the parentheses separate them, so that means multiply. So I'm going to multiply that whole thing by 2. So I'm going to have 3 to the 2 times negative x plus 15. And I'm going to have 3 to the 3 times x. So that's just 3x. Okay, so let's simplify this on the right. We want to distribute that too. So we're going to have 3 to the negative 2x plus 30 equals 3 to the 3x. Okay, now are we in the right form? Yes, our bases match. So now we can look at the exponent. So this exponent has to be the same as this exponent. Alright, so our equation becomes negative 2x plus 30 equals 3x, and we need to solve. So this is linear. We want to get the x's on one side and the numbers on the other. So if I move the 2x over here, I've got 30 equals 5x, and I've got that x is equal to 6. So we can go back up and check that. Probably going to need a calculator because that's a pretty big number right there. Okay, so we get this x equals x. All right, so that's the main idea that we're going to use for this section in solving exponentials is can we get the bases to match? And if so, then we look at the exponents.